Today we're going to finish learning about the exponent rules by extending them to the zero and the negative exponent power rules. So this is Unit 6, Lesson 2. I added this in for you guys to have the two rules in just one spot, just written out instead of written in the algebraic way. So I'm just going to go over it quickly because I know you guys know this one already. The negative power rule we haven't talked about yet, but the zero power rule is just telling us that anything to the power of 0 is equal to 1. So for example, if I have x to the 0 power, that's equal to 1. If I have 516 to the 0 power, that's equal to 1. If I have something that's even an entire polynomial, let's say it's x squared plus 2x plus 4, and it's raised to the 0 power, it's still equal to 1. So no matter how big or how small, anything raised to the power of 0 is equal to 1, okay? Now there's this negative power rule, which I told you guys yesterday when we were dealing with those answers. We left them as negatives for now, but we can actually write any negative power as a positive exponent by writing it as a fraction in the denominator with a numerator of 1. So what the heck does that mean? Let's say we have 2 to the negative second power. Basically, you're just putting it in the denominator. So it's really over 1, right? We're using the reciprocal. I just flip it, put it in the denominator, and that exponent becomes positive. So basically, you're just banishing it to the denominator, and then it becomes positive, okay? Another example would be with a variable. So let's do x to the negative fifth power, for example, okay? I'm going to banish it to the denominator, so it's going to be 1 over x to the fifth power. Okay, and that's it. So we're going to get started right away with exercise 2. I'm skipping around as usual. So which of the following is not equivalent to 5 to the negative second power? So this is 5 to the negative second power. Using my negative exponent rule, which I just learned, I know this needs to go down into the denominator in order to make it positive. So that's 1 over 5 to the second power. Okay, so that is what it's equal to. So they're asking us which one's not equivalent here. So I'm going to cross this out because that is obviously the answer. I also know that 5 to the second power is 25. So 1 over 25 is also an equivalent answer. So it can't be choice 3. So now I have to decide which one of these is correct. Now hopefully you can all tell it's not going to be 1/10 because it's 1/25. But if you put this into your calculator, 1/25, I'll just show you. Or even if you put 5 to the negative second power, and remember you can use the caret, negative second power, it'll show you that it's 0.04, and if you do math frac, you'll see it's 1/25. Okay, so that is also equivalent. So one that's not equal is choice 2. Okay, not too bad, right? I'm going to skip over, oh no, I'm not skipping over exercise 3. Exercise 3 we are doing together. So we're going to see what happens when we combine this with function notation where we just plugging in values. So if I've got f of x is equal to 3x to the negative second power plus 2x to the 0 power, then which of the following is the value of f of 2? So remember when we're dealing with function notation, we're just plugging it in, plug it in, plug it in. So everywhere we see an x, we're going to replace it with 2. So using parentheses, this is 3 times 2 to the negative second power plus 2 times 2 to the 0 power. Now I'm just going to apply these new rules I just learned. So 2 to the negative second power, I was doing exponents first, right? Because of PEMDAS. Exponents. So 2 to the negative second power, I need to put that in the denominator, right? So this is going to be 1 over 2 to the second power. Okay, take a moment to think about that. And putting it under the 1 in the denominator. And then this is plus 2 times anything to the 0 power is 1. So this is 2 times 1. Okay, so now we're just going to handle this here. This is 3 times 1 over 2 to the second power is 4. So this is 3 times 1/4 plus 2 times 1 is just 2. So 3 times 1/4 is 3/4 plus 2. And at this point, you could have honestly just plugged this whole thing in your calculator. But 3/4 plus 2, and I wanted to show you, remember, to do a fraction in the calculator, do alpha, y equals, and enter for the first n over d. And you can plug this right in. You can do 3/4, just go to the down arrow to get to the denominator. And then to get out of the fraction, use the side, plus 2. And you get 11/4, which is not here. So your options are, you can go to alpha, y equals again, and you can say choice, is it 2? I can't remember, let's see, choice 2. Oh, no, that's to enter it, sorry. Hold on, 11/4. Okay, math. Frac alpha y equals 3. It should be choice 3. Changing a fraction to a mixed number. Enter, and it gives you your mixed number 2 3/4, which is choice 1. Okay? And of course, if you didn't know how to do that on the calculator, you could always just plug these in and see which one was equal to 11/4. Okay? So that's choice 1. Let's do one more. Let's do, okay, we'll look at exercise 4. So now that we have negative exponent rules, we can develop a third exponent law, and that's the division one. So we're not going to, we've already learned that, so we're not going to talk too much about that. So far what we know is when we multiply exponents, we keep the base and add them. And when we do power to power, we keep the base and multiply them. Now, I went ahead and did the division with you as well. When we keep the base and we subtract. So we're just going to review quickly. When you're dividing with exponents with the same base, you keep the base, which is x, and we subtract 5 minus 2. I'll write it out for you though. So this is going to be x to the third power. Okay? For b, it's the same thing even if it's number bases, because they're still the same base. So the base is 3, we keep the base, we subtract the exponents, 10 minus 5. So that's 3 to the 5th power. And finally, x to the 8th divided by x to the 2nd power, we're keeping the base of x, and we're subtracting the 2 exponents, 8 minus 2, so that's x to the 6th power. I'm going to take one little moment to show you why this works, okay? Let's just use part C. Remember, when you're dealing with exponents, it's expanded or extended multiplication. So x to the 8th power is really x 8 times. So x times x times x times x times x times x times x. Okay? Is that 8? 1, 2, 3, 4, 5, 6, 7. Nope, times 8. Okay, and it's over x to the 2nd power, which x to the 2nd power is just x 2 times, which is x times x. Now, when you divide a number by itself, it's equal to 1. So it cancels out, right? So what we would have here, if we divided this number by this, is this would be canceled out, and this would be canceled out. And what would be left? X times x times x times x times x times x, which is x 6 times. Oh my God. Mind blown. This is why that works, okay? That's why we can use these rules, because we are just shortening something that would take us much, much longer to do. Okay, so instead of sitting here and expanding all of these out every time and crossing out the repeats and then counting how many are left and writing it as an exponent, we're using these short, quicker, more efficient rules to help us. Okay, to write this is just a general rule. This is just the algebraic version of this rule. We are keeping the bases and subtracting the exponents. So that'd be x to the a minus b. Okay, so where am I? Exercise 5. Sorry. Okay, so now we have a pattern that works quite well if the exponent in the numerator is greater than that of the denominator. But does it still work if that is not true? So we're going to look at what happens if the denominator exponent is not smaller than the numerator. What's going to end up happening is we're going to end up with negative exponents. But all we're going to do is we're just going to change them to positive exponents by using the new rule that I just taught you. So for part A, we're going to keep the base, because it's the same, which is 2, and subtract the exponent, so 4 minus 4. So that gives me 2 to the 0 power. And I would normally be saying, oh my God, what do I do? But now I know that anything to the 0 power is equal to 1. So my answer is actually 1. How lovely. So let's do part B together. X to the 2nd divided by x to the 7th. So again, I keep the base and I'm subtracting 2 minus 7. I'm having a moment now where I'm thinking that you guys might switch these numbers so that the bigger one is in front. Make sure you don't do that. The top number is what's being, the first number, sorry. The top number is the first number, so you're not going to do 7 minus 2 just because 7's bigger. It's the top minus the bottom, so it's 2 minus 7. Okay, so that's going to be x to the negative 5th power. But now, we're at the point where we're never going to leave an exponent as a negative because now we know how to make it positive. All we have to do is banish it to the basement. So this is going to be 1 over x to the 5th. And now it's positive. Okay? Uno más. 5 to the 6th power divided by 5 to the 10th power. So again, we're keeping my base, which is, we're keeping the base, which is 5. And we're subtracting the exponents in order, 6 minus 10. Not 10 minus 6, 6 minus 10. Okay? So this is going to be equal to 5 to the negative 4th power. And I'm going to make that positive by banishing it down in the denominator. So that's 1 over 5 to the 4th power. Okay? And that's really how you make a negative exponent positive. It's really not terrible. Okay, we just have one more to do. Okay, so now that we see that the subtraction rule for exponents still works with negatives and 0 exponents, we just want to be comfortable that negative exponents indicate division and positive exponents indicate multiplication. So we're going to look at exercise 6 and we're going to look at this exponential function, and all we're going to do is plug them in and find our answers, but we're not using the calculator here, okay? So we're just plugging it in. F of x is equal to 16 times 2 to the x power, okay? So what I'm doing is I'm replacing the x with 0 here. So f of 0 is 16 times 2 to the 0 power. So just don't forget, the super important thing here is that you follow the order of operations. This is not going to be 16 times 2 raised to the 0 power. This is 2 to the 0 power first because exponents comes first. So it's going to be 16 times anything to the 0 power is equal to 1. So f of 0 here is going to be 16. How delightful. That's your answer. Okay. You know what? Why don't we don't really get to do this enough in this class. Why don't you guys pause and do B and C and then unpause it to see the correct answers. See if you can do it on your own. Ta-da! So for part B, you should get 64. That one was pretty easy. You just replaced x with positive 2. Make sure you do your exponents first. 2 squared is 4, and then multiply by 16. That gives you 64. And then this one, we have a negative 2. I started plugging it in on accident first. But before you do anything here, what we're going to do is we're going to change that 2 to the negative 2nd power to positive by putting it in the denominator with a numerator of 1. So that's 16 times 1 over 2 squared. And 2 squared is 4. So I got 16 times 1/4, which is the same as 16 over 4, which is equal to 4. Okay, so that's that. I'm going to, I think for homework, I only gave you very straightforward questions to practice this with, okay? But yeah, the most important thing is that you're able to recognize anything to the power of 0 is 1, and any negative exponent can be written as a positive by putting it in the denominator with a numerator of 1. Okay, any questions? Let me know, guys. We're going to be having our Google Meets. What did I decide? I think Friday. I will, don't call me on that. I'll let you know on Google Classroom, but if you have any questions, have them ready, and I'm pretty sure I said Friday. Okay, guys, have fun with this.